Thank you very much. All right. Thank you very much for a very kind introduction. As you're aware, the title of my talk is Clutching at Random Straws. Most of this information was just presented to you. My name is Matt Parker, as advertised. I'm based at Queen Mary, University of London in East London. And this is my email address. And I'll put this up again at the end. If you've got any questions or overly elaborate heckles and the like, you're welcome to email them to me. I should point out, though, and this was mentioned before it came up, in the phrase stand-up maths, there's only two real promises that I'm committing to. One, I will be standing up, done, and maths, which, believe me, is about to occur. There is no guarantee of entertainment, although just for you tonight, I have written and will deliver a joke. And it's quite the joke. I'm looking forward to this. And if you are on Twitter, if you include the @ symbol, that's me on Twitter, although don't attempt to do that during the lecture, or I will victimize anyone who I spot using a phone. Or if any of them ring, I am totally qualified to confiscate and answer in that order any calls. I will. Any calls that come in. Because I used to work... you guys having a little group discussion. See, look, boom, there. See, I can detect people talking. It's like a teaching ninja. I can just... Wouldn't that be great? A maths ninja. Instead of shurikens, I'll throw prime numbers. Anyway, that's not the joke. It gets better. I used to work as a maths teacher. Originally, I went to the University of Western Australia, and I started off studying, of all things, mechanical engineering, before I realized the very real risk of me being employable at the end of it. So I switched into physics and then into maths, and absolutely loved maths. And that's when I thought, what can I do for a living where I just get to talk about maths? And so I became a maths teacher. I moved to London after having taught in Australia for a bit. I taught in London for a while. And then I got into kind of support education. So I worked with universities and other organizations to do talks about maths and how much I enjoy maths. And someone opened a can of drink. We've been through this, right? What is it? No, this is not television. I can see you. We're having a conversation now. It's a non-consensual conversation, I give you that much, but it's happening. What are you enjoying? Pepsi. Oh, you can keep that, right? Coke or better, you'd be in trouble right now. Okay, I'll be nice to you guys from now on. That's what we're yeah, apart from Pepsi Boy. It's on. You and Group Theory Lad, both of you, I'm watching. One false move from either of you. For those of you watching the DVD, that's a hilarious reference to the previous lecture. Anyway, I've only got a finite amount of time for this as well. Anyway, where was I up to? Oh, yeah. So I worked for some universities for a while. I started, as the teachers here will appreciate, I started to get a bit nostalgic for the classroom. So just recently, I went back for 2 terms. I thought, it's only going to be 6 months. I can survive a lot. So I went to a North London Comprehensive School for 2 terms. And that cleared that right up. I was like, I'm good with teaching now. So now I'm based at Queen Mary University. I'm in the maths department. And because they asked very nicely, I dabble in the physics department. And it's my job to both work with the academics and the students and post-grads and whatnot to help them communicate their maths and what they do to other people. And I go into schools and do talks like this. And I have the joy of doing a bit of media work and writing about maths and generally anything I can do to get more people more excited about maths. And just to see where the audience is at, I'm going to do a quick informal survey. I'll state my definition first. If you are a maths teacher or a mathematician or an overly passionate maths student, I'm going to classify you as in the maths-friendly group. All the maths-friendly people give me a cheer now. And 1 round of applause. Who was that? Well, there you go. Well, thank you very much. The trouble with applause, as you will notice, very much a group activity. But it was a good start. And everyone who is in the compliment set, the other people, give me a cheer now. Yeah. at the back, of course. Don't think I can't see you. We've established that. I like to check the people I'm talking to. And if I'm not in a situation where I can do an informal survey, I have a very simple litmus test, if you will. It lets me know how any given maths talk is going to go. And you guys have passed in flying colours. Because of this guy here. Sir with the glasses and a very nice beard. Would you mind standing up for a second? Just, yeah. I know a gig will go well if someone's made their shirt out of graph paper. And then can you give him a round of applause? That's... You take a seat. That is a good sign. Anyway, my talk today... I'll explain more about what I'll be talking about, but I thought before I even do that, you know, it involves randomness and it involves clutching at things. I thought I would just start by showing you what got me into this area to start with. And it was on my way. Actually, I was on the tube on the way to Queen Mary one morning, and I was flicking through the fine scientific journal known as the Daily Mail, and I came... It's kind of a punchline on its own there, isn't it? And I came across this article here. And this is the picture that went with the article. There were words. It was a retired marketing executive who lives in Devon. And what he had done is gone through and taken all the ancient, prehistoric kind of monolithic sites in the UK, put them on a map, joined them up with some lines, and discovered that some of them, wait for it, formed triangles. And not just any triangles. There were some equilateral triangles, there were some isosceles triangles, and he got very excited about these. And he wrote to all sorts of various publications talking about these triangles. And his theory was that these triangles were so precise, they must have been done on purpose. He actually said, you cannot do that by chance. These triangles are so precise. The isosceles triangles are so precise. The equilateral ones are so spot on. And his theory was that there was some form of ancient sat-nav, or that they were a way of navigating, so you would use these incredible triangles to navigate from one spot to the next. And he figured that the ancients living in the UK had positioned these sites partly for that purpose. And he actually said, I haven't put it up on the screen here, he said he couldn't rule out extraterrestrial help. So precise were these triangles. Now, some of you are shaking your head in a skeptical fashion. I thought, well, maybe he's onto something. Maybe, I mean, these are, don't get me wrong, the triangles he found are incredibly precise. And so I got to work, went up to my office in the Mass building, and thought, I wonder if I could use this same technique. And so I did. Here is a map of the UK, centred around where we are right now in Birmingham. And I looked up where a whole set of ancient sites were, and I found 3 of them that go right around Birmingham and form an incredibly precise equilateral triangle, within 1% accuracy. And I thought, well, I've got to step this up a notch to isosceles. And so I found 2 more sites on either side that give isosceles triangles within 0.5% accuracy, and indeed another 2 sites which can extend a bigger isosceles. There are isosceles within 0.5% of the 2 sides that should be the same length. And then I extended the base of the equilateral triangle, and I put the perpendicular bisector through it, and formed this cross structure centered around 4 additional sites. And just to show you how accurate this is, the base line goes right through the base of my equilateral triangle. Up here is Conway, down here is Luton. This line is 173.8 miles long. It is within 40 feet of the Conway site. It is within 30 feet of the Luton site. These are mind-numbingly precise geometric arrangements. And I was just amazed. The unfortunate thing was I wasn't looking at prehistoric ancient sites. The ancient sites I was looking at are the old Woolworths stores. Please, they're there. If you want a copy of these, I will email them to you later. These are where Woolworths stores used to be, and they do form these incredibly precise triangles. And so, I mean, but we don't know what they used them for. I mean, who knows how the ancient Woolworths civilization lived? I mean, how did they buy discount CDs and cheap kitchen goods? We just don't know, but we can investigate it with this. And at this point, to be honest, I can't rule out extraterrestrial help. How else could they offer the Ladybird clothing range at such low, low prices? Anyway, these are the real stores. They are that accurate. I wrote this up as a pseudo. I haven't published this as a real paper. Any mathematicians who wish to lend some of their time to me, I'm keen to do some more with this. But I put out a press release, which is a lovely thing to do. And it was picked up by bits of media, and I got media coverage of the ancient Woolworths civilization research that I was doing. And a lot of archaeological kind of magazines wrote to me and said, look, we really appreciate what you've done, because now we know this guy's a bit of a crackpot. Be careful what I say here. So we know that these triangles could have happened by accident, because they have happened by accident with the Woolworths stores. In fact, if you look at all the Woolworths stores in the UK, I had all of these to choose from. It's not hard to find triangles when you've got that many sites. I literally printed out the Google map of the UK with all the sites on it and got a ruler and just worked around until I found these. And then put the locations into the computer and crunched the actual numbers for the alignments and how accurate it was, and then put it out. And it's just a case of I had enough data, admittedly, effectively random data. I had enough of it that I could just flick through, find the few sites that matched what I was after, and ignored the rest of them. And that is the whole point of the talk I want to do today, is that if you've got enough data, you can find patterns that have no meaning to them. They're only there because you've got enough data. But if you're prepared to ignore most of your data, you can pull one of these patterns out and prove pretty much anything you want. One of the best things about doing this is I got an email from a maths department, which, I shouldn't get this wrong. I think it was Liverpool? I think it was Liverpool University. Someone sent me an email and said in their group they've now got a new expression for when people are selectively analysing data. It's called pick and mix data analysis. That's brilliant. But there's a whole area of maths. It's called Ramsey theory, if people want to look it up afterwards. And the idea is, if you get enough data, you can find any pattern you want. But more than that, if you have a sufficient amount of random data, you can find any pattern you want to any level of accuracy that you want. You just need enough data to start with. And I thought I'd illustrate this with a simplified version of Woolworths. So imagine this rectangle, which is ever so slightly off to the left, is our entire world. And we're looking for equilateral triangles when we get random points put on this surface. So let's say we've got one point there, no triangles yet. We've got another point over here, still no triangles. Now at this point, the next spot we put in, if it falls into either of these two zones, we will have an equilateral triangle. And the size of that disk is the level of accuracy I'm after. If I wanted more accurate triangles, I could have smaller disks. If I don't care so much, I can have bigger disks. And so the next point comes along, and let's say I miss. Let's say it's up there. Now all these spots have opened up as potential equilateral triangles. If the next dot doesn't fall in those, these spots would now give me an equilateral triangle. If I miss those, now these spots open up. And after a while, it becomes more likely that we will get an equilateral triangle than we won't. And with enough data, it becomes inevitable, given on your level of accuracy. So the smaller I make these dots, I just put more and more points in until it's impossible to not have an equilateral triangle. It's bordering on something called the pigeonhole concept. We'll run with that. Where often you can tell that something has happened just because you've had enough data as such. And a great example is with the room here. I checked, and there were 350 tickets sent out for the talk tonight. And with other people in the room and whatnot, we're dangerously close to 365 people in this room. But if you imagine it, if we all started outside the room and we started sending people in and we said, look, we've got this great idea for seating. We've marked all the seats with a day of the year. Find whichever seat has your birthday on it and sit there. And we start sending people in. Sooner or later, there will be a chance that someone's going to walk up and find someone else who's already in their seat. There's a chance that two people in here will have the same birthday. And if we send in more and more people, it gradually becomes more and more likely that's going to have happened. And at some point, once you've sent in 365 people, conceivably everyone is sitting in a different seat. Or if we include leap years, if you send in 366 people, you know that there could possibly, one person could be in every single seat. Incredibly unlikely, but it could happen. The moment you send in the 367th person, they have to sit in a seat with someone else already there. And if we then sent in another 365 people, eventually would be guaranteed that 3 people in here would share a birthday. So there becomes a point where you have enough people in the room, it's inevitable that there will be a birthday in common. Now, that's in the extreme case. Now, what's interesting, and this is a slightly different concept, and I will elaborate on this afterwards, but it's curious to think how many people would it take? Where's that crossing point between where it's unlikely 2 people are sharing a birthday to where it's likely? And a lot of people have heard this. It's called the birthday problem, and we're going to do it here today live in front of you. But I want you to, don't call anything out, but just have a think. How many people you think it would take in a room, so just imagine you're in a room with loads of other people, for there to be a greater than 50% chance there's a birthday in common. People have seen this before. I'm also curious where the 70% line is. So if you know how many people it takes for 50%, see if you can have a guess at 70%, just to keep the game fresh. Now, we can work this out. We can do this with maths. And the best way to do it is to imagine you've got a party. So I've got a picture up here. There's my room. This is a party in progress. Bear with me here. And what I've done with my party is I've made everyone leave the party, go outside, queue up, and I'm going to bring them back into the party, one person at a time, and I'm going to keep track of what the probability is that there's a birthday in common. So the first guy comes back into the party. And he's very happy to be back. And at the moment, he can't share a birthday with anyone. So now it's a 100% chance there are no birthdays in common. We bring in the second guy, who's even happier to be back. Now, there's a chance their birthday is the same. There's a chance their birthday is different. Because the maths is slightly easier, I'm going to look at the probability their birthdays are different. And I'm going to ignore leap years for now. Because without leap years, when the second guy comes in, his birthday just has to be different to the first guy. And there are 364 possible days out of 365 where his birthday is different. So that's our probability that his birthday is different, quite high. We then bring in the next guy, who promptly has a seizure. And there's now 363 days that his birthday could be. So we need the first guys to be different to the second guy to be different from the first guy, and the third guy to be different from the second guy and the first guy. So we multiply this by the 363 out of 365 chance the third guy is different to the first 2. We bring in the next guy. Yeah, I got nothing for that. And we then multiply the running total by the 362 days his birthday, and we can carry all the way down. And so you gradually fill the room with people, and you keep track of the fractions. Now, a few people very correctly are now thinking that this doesn't look much like a party. And I'd like to say, if you're thinking that, you're completely wrong. This is the one joke. Enjoy it. This is it. Oh, forget it. That was dramatically funnier on the inside of my head than the out. Anyway, we'll do this as a table, right? So over here we've got the number of people in the room. We've got the probability their birthday is different. And we can do this as fractions, which we had to start with. We can then take those fractions, convert them into a percentage. And then to get the probability of one or more birthdays in common, we just take the complementary probability, and we can run that all the way down here. And by 5 people, it's only 2.7%, not dramatically high. And by the time you get down to 10 people, it's only 11.7%. Now think of the number where you think the 50% line is. If you come all the way down, it's actually at 20, we're at 40%. There it is there, 23 people. The moment you have 23 people in a room, there's a better than 50% chance there's a birthday in common. And for the people trying to guess 70%, that's down here at 30. 30 people in a room, 70%. Now, we have a dramatic well, we got a much bigger group than 30. And so we can test this, because the maths does not agree with our intuition. Our intuition, most people I ask, what do they think the probability is? They guess between 1 and 200 on average. But yet the actual number is 23. So we're going to check. And we're going to do this quite systematically. And what we're going to do is I'm going to use the front row to start with. I'm going to start with you, sir, and we're going to come across the front row, and we're going to weave our way back. And the way this works is when I point at you, I'll go first and show you. When I point at you, call out your birthday, not the year, just the date. So everyone think, make sure you know your birthday. It's really embarrassing if you don't. It's hilarious for me, embarrassing for you. When I point at you, shout it out. So, for example, my birthday is the 22nd of December. And so, as I go around, if you hear your birthday called out, don't ruin the surprise. If you hear it, it's your job to remain completely calm. Wait until I get all the way along. Don't give it away. When I get to you, that's your moment to explode. When I point at you, can you jump up? This is compulsory. Jump up and shout, my birthday is the 22nd of December, or whatever. My birthday is, insert birthday here. Same as that guy. And this is also compulsory. And point at whoever it is, whose birthday is the same. Are you ready? Okay, here we go. Without talking. Thank you. Okay, here we go. Are you ready? Sir.
21st of April.
21st of April.
4th of August.
4th of August.
17th of July.
17th of July.
11th December.
11th of
December.
December.
1st of January.
1st of January.
17th of August.
17th of August, very confident, good.
13th of February.
13th of Feb.
12th of August.
12th of August.
1st of April.
1st of April.
12th of May.
12th of May, hold it there, wait. Okay, no batches yet. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we've gone through 11. Where's 11? Oh, wait, sorry. Okay, 14.1% chance that will have worked so far. A much greater chance it won't have worked. So I'm not nervous just yet. Okay, where are we up to, Miss?
28th of December.
28th of
December.
December.
14th of August.
14th of August.
7th September.
7th of September.
18th of June.
18th of June.
10th of October.
10th of October.
23rd.
23rd of March. Okay, hold that. 11, 12, 13, 14, 15, 16, 17. Still not nervous. 30%. Now, just as a challenge for the microphone people, next row back. So have you got?
27th of March.
27th of March.
15th of April.
15th of April.
19th of June.
19th of June.
3rd of April.
3rd of April.
30th of January.
30th of January.
23rd July.
23rd of July.
Would you do me a favour and just repeat that?
Oh, 23rd July.
That hasn't changed, yep. Maybe she's making it up. She goes, you're just trying to hack into my email, aren't you? And now, could we do the same game with mothers' maiden names? No. Sorry, yep.
5th of November.
What?
5th of November.
5th of November.
25th of July.
25th of July. Hold it there. Where were we up to? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So at the moment, 57% chance. So now I start getting mildly nervous. I won't get truly nervous until the end of the front row.
22nd of January.
22nd of January.
17th of September.
17th of September.
1st of December.
1st of December.
December 18th.
18th of...
December.
I'll mess with the format. 18th... No, that's okay.
21st of June.
21st of June.
30th of October.
30th of October.
19th of December.
19th of December.
17th of July, which is the same as yours, isn't it?
Whoa, that's not... No. Pause the cameras. Can we try... We'll do it again. We'll go back one. Everyone else, put your board faces back on.
19th
Yes.
of December.
Yes, and you, sir?
17th of July.
You try and work with professionals and look what happens. Is it the same as the...
Yeah.
Should we have a round of applause anyway?
Yeah.
Let's do it. 25, 26, 27, 28, 29, 30, 33 people. Okay, and just as a quick test, we only called out 33 people's birthdays. If you'd heard your birthday, put your hand up now. Who? Okay, so a substantial number. And that's just calling out these. It goes up exponentially the further along we go. I think this is phenomenal. This is a great example of counterintuitive probability. And I'm going to go through a series of things in this talk which are why we leap to conclusions based on patterns and evidence which in fact are meaningless. And the first way that we jump to meaningless conclusions is when we don't appreciate just how much data there was, and we've just selectively picked out the bits that match what we want. The next thing I'm talking about is that we often don't appreciate just how likely some things are. If you meet someone with the same birthday as you, you get amazed. If you believed in fate-related things, you could attach all sorts of meaning to that. And in fact, meeting someone with the same birthday as you is quite unlikely. But you do meet hundreds of people. And if you don't care who it is, so we didn't get to someone with the same birthday as me, we were just looking for any match. And that gets incredibly likely very quickly. And you can actually use this to win hypothetical money off your friends, if you're so inclined. Because if you look at the graph, and I do enjoy drawing graphs, and on the x-axis you have the number of people in the room, y-axis probability of there being a birthday in common, the graph starts at 0 and flies up very sharply, and then flattens out. And our 30 people line is up there at about 70% probability. By the time you get to 60 people, that is over 99%. And it will sit just below 100% all the way along until you get 365 or 6 or 7, depending on how you're doing your calculations. But once you get there, it's mind-numbingly likely. For me, though, 70% is pretty good. Because 70% of the time I do that, I get it within the first 30. The other 30% I don't. So what you can do, right, is the next time you're in a room with 30 people or more, you just bet someone 10 quid there's a birthday in common. And hypothetically, and 70% of the time you will win, 30% of the time you will lose. And today I would have lost. I would have lost £10 on this. But that's the great thing about probability. Even though you don't know if you will win or lose, you know what will happen in the long run. And should you simulate your results and plot them on a graph, and I do enjoy drawing graphs, it will look a bit like this. Some of the times you will win and your takings will go up, and sometimes you'll lose and they'll go down. Number of bets on the x-axis, money on the y. And in fact, I mean, here there's a big losing streak, a couple in a row there. But you know, if you win more often than you lose, over time you have to go up. It's how casinos work. They hire mathematicians and experts to make sure every single game there's a slightly greater chance the casino will win than you will. So even though some people win, some people lose, over time the casino always wins more than it loses. They can't help but make money in the long run. So I hope you're not covering up your graph paper t-shirts with a... Is it a grey cardie? That is acceptable. Carry on. Now, how's the Pepsi going? We good? Good. And group theory boy, any comments yet? No? Marvellous. Just thought I'd check in with all the people we've met. There will be more. Still, good. You're still keeping everything under wraps, under control? Good. I rely on you to keep calm. Anyway, I'd like to show you another example based on a very similar concept. I've got 3 packs of cards here, and I'm going to give them to 3 volunteers, one of which has to be you. There you are. Can you take those? And can you start shuffling them? Someone over here who looks mildly interested. You. And then someone, there you are, someone at the back who can catch. You guys are way over optimistic. Ready? Whoa! There you go. All right. Now, if you've got a pack of cards, can you start shuffling them so that you think they're in a random order? And just there's a full deck. They started in a random order. I gave them a pre-shuffle, and this has actually been done as a magic trick. A magician will get someone to shuffle cards You could hypothetically bet hypothetical money on the outcome. And you will say, I bet while you're shuffling these cards, I can control them. I can control, specifically, the king and the queen. I will make the king end up next to the queen, or at most one card apart. Get them to shuffle for a while, and then get them to check. If you've got the cards, can you flick through now, see if there's a king next to a queen, or at most one card apart? So a king, something else, then the queen. Can you ever flick through and... You're just showing off now, aren't you? Now you decide to shine. Not when I needed you. Okay, can you have a flick through and see if my... Not one card at a time, just... Oh, seriously. You'd think I would have learnt my lesson last time, wouldn't you? That's... Okay, and can you have a look through? Let me know, have you found them next to each other? Next to, up the back, next to, and then over here. I'm going to go with yes. You've done, yeah, okay, 3 next to each other. Give these guys a huge round of applause. If I said, what are the chances, if you shuffle a pack of cards, that the king ends up next to the queen, you would think that would be quite an unlikely event. But we just had it occur 3 times in a row. And I have actually gotten off quite lucky, actually. Next to each other comes out at about 48% probability. And I'm being vague for a reason I'll explain in a moment. And next to or one apart is more than 67.2%. And I've heard arguments it's about 74%. It's not as easy to work out as you would think. If you're bored, have a go. It's a brilliant activity. Start with next to, and you should get something about 48% if you try and work it out logically. And then if you've got a handle on that, have a go at next to or one apart. I've seen people argue that it should be about 74% in theory, and I've seen people simulate it and come out at about 67%. But both methods are trickier than you expect. So please do have a go. Not now. Some people are... No, yes, you with the pen, I can see. Marvellous. Good, good. Unless you're writing a note to the person next to you. You wouldn't believe what he's asking us to do now, is it? Yeah, maybe tonight, or tomorrow night. You're busy tonight. Maybe tomorrow night. Invite some friends over, right? Have a mass party, yes. You've had a mass party, they're great, aren't they? And so you can... We'll talk later. You'll get on really well with group theory, Guy. I'll introduce you guys afterwards, seriously. Anyway, whether or not at a mass party, you can try and work it out. And it's harder than you think, but it is, without a doubt, more likely than you expect. It's yet another case where our expectations are for a much lower probability than actually happens. Again, partly it's because you underestimate the number of opportunities it's had to happen. There are a lot of pairings in a pack of cards. And even though it is quite an unlikely event, there's a lot of opportunities for it to happen. Same with the birthday thing. There are a lot of pairings by the time we get to 30 people that even something quite unlikely becomes very likely. My all-time favourite example of this is this photograph here. This is a photograph taken in Disneyland. And... Disneyland, they annoy me for several mathematical reasons. But one of them is their just assault on the notion of scale. How can you have a giant version of a dwarf? That's... No one part of that makes sense. Anyway, the point in case here is this character here with her arrow, not mine, is indicating Donna. This is a photo from when she was a kid. She's now grown up. And she was sitting down with her fiancé, Alex, and they were flicking through photos of her childhood, because we all know that's an enthralling experience. And they were looking at the photos of her trip to Disneyland. And Alex looked at it and went, wait a minute, that guy in the background, that looks like my dad. And that is Alex. They didn't meet until decades after this photo was taken, but in their childhood, they were accidentally photographed together just because they happened to be at Disneyland on the same day. And I think that is amazing. This ranks as one of my all-time favourite photos. I think this is absolutely phenomenal. And for the people involved, it's amazing. For these guys, I mean, what a thing to have. And they checked. They got photos from Alex's trip and compared, and his dad was wearing exactly what he's wearing in the background of this photo. An incredibly unlikely event. But I would argue that despite being an amazing, unlikely event, it is still to be expected just due to the sheer number of photographs that we all appear in. If you think how many times across the course of your life, particularly now, you've been photographed with other random people in the background, and you try and work out how many random people you've been photographed with, it's not as alarmingly unlikely. It's still mind-numbingly unlikely, but not quite as mind-numbingly. And then if you think that that applies to every single one of us, there are so many opportunities for one of us to happen to have been photographed with someone that we then met later on in life. So it's a bit like winning the lottery, in my mind. It's amazing if it happens to you, but it shouldn't be a surprise that it happens at all. Very unlikely events will still occur if they have enough opportunities. With enough opportunities, they become inevitable. And this is kind of my second and a half point. There are things that we think are really unlikely. In fact, they're much more likely. And a lot of the times, we don't appreciate just how many opportunities something has had to happen. And I don't want to diminish amazing things when they happen. These freaky coincidences are amazing, but we shouldn't be surprised when they happen. We should be more freaked out if they never happened, because then we know something strange is up. But the fact that they do occur periodically, and if you never have anything freaky happen throughout your life, you're a bit unlucky. If something amazing does happen, then that's kind of your allotment, I guess you could say. And enjoy it. It's phenomenal. But it doesn't mean it's unexpected. And I think I've laboured that point sufficiently. I'll labour it some more afterwards. Please come and see me if you require more labouring. Anyway. I did actually write down important points I wanted to get through. Okay, here we go. Oh, this is kind of fun. Moving into my third point, we want to see patterns. As humans, we thrive on patterns, and I think that's great. Originally, I mean, I'm not very good with biology and the like, but you can see why evolving the ability to search out patterns and to be hypersensitive to rounding up risk are very good survival tactics. And the notion of we spot patterns, we round up to the nearest pattern, is what I'm trying to say here. And that's a great thing to have. And it's the reason we do maths. It's because we love spotting and working with patterns. That's why mathematics exists, partly. People can come and argue with me afterwards. But I will labour you. And I think that's great, but we forget just how tuned we are to wanting to see patterns where there may not be any. And one of my all-time favourite examples of this is what's called backmasking, which is where a band is recording an album and they're laying down the songs, and you think, guys, you know how Satan is our unholy master? We should record some messages about him backwards and hide them in the song. And this was all the rage in the 70s and 80s. And people used to... I don't want to speculate who sits at home listening to album after album backwards in the hope they will find someone trying to brainwash the youth of, now yesterday. But they're still going. So here's an example. This, for those of you who are unfamiliar, is Lady Gaga. Her husband, Lord Gaga, is not featured in this photo. And you should all be ashamed for laughing at that. I should make that very clear. Anyway, she had a hit, or had several hits, and one of them was Paparazzi. And if you're unfamiliar with it, it goes not unlike this.
I'm your biggest fan, I'll follow you until you love me. Paparazzi, baby, there's no other superstar, you know that I'll be your paparazzi.
Okay, that's the song. Forwards. I'm now going to play part of it backwards. See if you can spot what people think this says. Here we go.
People say no,
Any guesses? Anyone want to hazard a guess? Even a word they think might be in there? Lucifer, very good guess. Beelzebub, nice. You're trying to top trump his number of syllables, aren't you? So you're saying maybe Lucifer, maybe Beelzebub. No one heard evil save us. The stars above, we model it on the arts of Lucifer. 2 points to you. What?
I heard exactly that.
You heard exactly that, word for word. It might be best for you to leave by a different exit. Are you a teacher?
A little bit, yeah.
A little bit? I dabble. I'm not invited to the school, but I go. I'm liking you more and more. Anyway, I'll play it again. Watch this, and you will hear this word for word. Are you ready? It's there. You look unconvinced. No, but you can. The second time through, I'll bring it up again. You hear those words. Now, people often aren't convinced just how important the suggestion is. People think maybe you hear it a few times, you'll start to spot it, or it's a slightly different recording each time. And I want to clear all those notions out. I want to show you it is solely the fact that you have been biased before you hear it. And if you're biased, you will spot the words. If you're not, you won't. And to do that, I'm going to use a different song. This is Freddie from Queen, who was gay. Who knew? You should be more ashamed at that than the Lady Gaga. Anyway, quite a nice song. Another one inevitably will bite the dust. Goes like this. And I'll move it, but this will not stop. I'm now going to play this one backwards. When you go home, you can download it, having paid for it legally on iTunes, if you want. Don't laugh at that. This guy's here going, I'm going to do it illegally. I'm going to play it backwards. If you think you hear what this is, don't call it out. Just see if you can work it out. And I'm going to loop the same bit over and over. Here we go. Have your guess what it is? Right. Some people think they might have it. Here's what we're going to do, and this relies on you playing along correctly. I'm going to split the room in half. So down here, right down the middle there, this whole half here, I want you to, when I say go, not now, you're going to close your eyes. And this half, I'm going to show you what he's saying. So this half will know, this half will not. You guys are actually the lucky side. This will be more amazing for you. Okay, ready? Everyone on this side, close your eyes now. Everyone on this side, don't call it out. That is what he's saying. Okay, this side, open your eyes again. I'm going to play it again. If you can hear this, put your hand up. Here we go. Who can hear that on this side? Who can hear that clear as day? Who can hear it on this side? Who has no idea on this side? Who can hear it on that side? It is the suggestion that means you can hear it. I can say this all day. These guys think you guys are really thick right now. Because it's blindingly obvious to them. It's getting catchy. I think that is absolutely amazing. That it is. If you had that suggestion, you will hear that over and over again. If you haven't been primed, you won't. And this comes up time and time again. If you're told there is a pattern, you will spot it. And now all of this stuff starts to come together. So if you get enough random data, and first of all you're told there's going to be a pattern, you'll be searching for it. If you have enough data, you will find it. And if you're unaware of just how likely it becomes, you will think it's amazing when in fact it's unavoidable. And it means that we are constantly coming across people who will back up their argument with patterns and with evidence that simply does not stand up. But that's why we have science. That's why we have maths. It's so we can overcome our human intuition and actually get to the cause of the problem and actually see, is this a significant finding or is it just random noise? That is the beauty of maths. Maths exists separate to our brains. Maths doesn't care how our brains work. It exists. But we can use it and we can learn how to think in ways our brains normally wouldn't. And we can use it to overcome this problem. And so, for example, just very quickly, I've got a little bit of spare time. There's a problem when you do surveys, like food testing surveys, that you don't know if the results you're getting are significant or not. So if you wanted to decide between Cola A and Cola B, you, sir, are drinking Cola B, and so you ask a bunch of people, here, drink Cola A, drink Cola B, tell us which one you prefer. If one of them does genuinely taste better, or whatever you're trying to find out, you should get more results that say Cola A over Cola B, or whatever your investigation is. If, however, they are actually identical, people are still going to pick one or the other. So you ask one person, Cola A, Cola B, they say Cola A, you go, very nice. You ask someone else, Cola A, Cola B, they pick Cola A, you go, well, it must be Cola A tastes better. Or, this is what's called the null hypothesis. Assuming that there is absolutely nothing to it. Assume both the drinks are the same. Assume the medication doesn't work. Assume that there isn't another planet around that star. Whatever the zero case option is, assume that and see how likely the outcome is now. And if both colors are identical, you can say, well, if they're picking perfectly at random, there's a 25% chance I would have got this result. And now that's not, it's a 25% chance that there is nothing to find. It's saying if there is nothing to find, this is a 25% chance you'll get these results. It's subtle, but that's the power of maths. We can pin this right down. And it's generally agreed, if you get that probability down to under 5%, you've found something worthwhile. Bigger than 5%, you need to put a bit more work or do more studies, or maybe there is nothing. And we can do these things properly. If people just pluck out random locations in the UK and make triangles and pick the ones that fit and then publish it in the potentially not peer-reviewed Daily Mail, then these things go straight into the public eye. And this is where I'm going to go into my call to arms phase, which is why I asked for the close-up shot. You'll notice also I asked very nicely if they could organise for me to have a piano on stage, which they did. That was going to be for my closing number, but I don't think I'm going to have enough time to fit it in. But that was very good of them to... And I said, look, don't just put it there. Make sure you put a crash barrier in case the crowd rushes forwards. So, thank you, University of Birmingham, but I'm not going to be using it. Where was I? Oh, yeah, call to arms. Bear with me here. If mathematicians don't speak up, and if scientists don't speak up for what is good science and what is good maths, then people will put out these crazy stories. And it will look like it's good because they will have evidence, they'll have data. And unless people come out and say, well, actually, this is how science works, this is how we do the maths, you can find these patterns, or it's more likely than you think, or that's because you were looking for it, then the pseudoscience stuff will continue. And I'm adamant that we need more people, mathematicians, prepared to step out into the media domain and do this. And so if I can get one passionate plea, if we don't... People want to hear about scientific breakthroughs. They want to hear about good maths. And if we don't fill that void, crazy people will. And so we need to get there and do it. And if the crazy people speak up, we should say something. And there's this kind of, I call it the specialism fallacy in science, where scientists are so used to having their specialism and they won't speak outside that, which works wonders in science. But if you're the person thinking, oh, am I quite qualified to speak about this, it's not quite my area, you're exactly the person Just that thought process alone means that you're someone who should be out there speaking up for logic. And I've got a whole rant about homeopathic remedies that I'm not going to do now. But these things continue if people aren't prepared to say, this is how we do science, this is how we know what works. That is a pattern that has no meaning behind it. And I'm done for my rant. That's it. My opinions on homeopathic remedies are a matter of public record. I'm being careful. I don't want this to all go all Simon Singh on me, if you will. Anyway, I thought I would end with one of my all-time favourite examples of if you have enough data, you can find whatever you want. Actually, any guesses? Does anyone want to hazard a guess what I haven't covered? What was that? The what? The Bible. The Bible? If you write enough books. No, actually, you're spot on. No, he's right. It's the Bible Code. I would like to end to talk briefly about the Bible Code. And the Bible Code goes like this. You get part of the Bible. And you should do this in the original Hebrew or it's not ancient Greek, New Testament Greek, or whatever it was originally written in. You write it out, you take the spaces out. And I'm going to do it for the purposes of this. In English, this is the NIV translation. This is 1 Kings chapter 4, verses 13 to 23, in case you're playing along at home. And I'm not saying anything about the Bible as a religious text. I'm just saying if you take any book and you take out the spaces, you end up with a grid of words. Now, the way the Bible Code works is they look at all these letters and they ignore the original surface reading, the original text, and you try and find hidden words by starting with one letter, skipping a set amount to another letter, skipping a set amount to the next letter, and you spell out hidden words. So I thought I would check the Bible for any predictions about today. Because what people do is they go back and they say, if you jump every 17th letter, this spells out one word, and if you, then this way another word, and it was a prediction of the assassination of someone or a particular tragedy or whatever. And they can show all these words crossed and predicted this was going to happen. So I checked this morning before I started if there's anything for today. And some of you may have spotted the word 20 is here. And that's just in the text as such, the word 20. And that is allowed. That's just a jump of one letter each time. But it's not the 20th today, it's the 29th. And so the word 9 appears up there. N, jump I, jump N, jump E. Equal distance each time. And because of the way I've wrapped the text, it means they line up. Because I've got the same number of letters per line. So the 29 of September, here we are, I got bored. So 29 September, all crossed in this part of the Bible, in 1 Kings chapter 4. And so this must be the bit about today. And what's happening today? Well, I'm here giving a talk to you, as was Dorothy Buck. And so here is Matt. M, it's 30 letters. M, 30 letters A, 30 letters T, 30 letters the next T. Matt, bang on. And some of you will have spotted down here, Buck. There we go. So, Matt and Buck will be giving a talk, about what you would want to know. So I had a closer look, and Dorothy was talking about, here it comes, where is it? Let me see if I can spot it. There it is there, K, jump one N, jump one O, jump one T. Talking about a knot. There you go. And I'm talking about odds. There we are, odds that way. Getting a bit creepy now. The more OCD of you will have spotted, and I'm not even going to point this out, but up the top here, where is it? There it is. Math. Look at that, math. But I'm not going to highlight that. If it had been mathematics or maths or any other actual word, I would have highlighted. Not good enough. And this is freaky, but it's exactly the same thing. I could find today's date with both of the speakers' names and both of the topics we're talking about, because there's just so many letters. You think of how many letters in the Bible, and for each of those, how many different jumps you can do from it, that it just becomes inevitable. I've done this talk a few times, and I can always find a prediction for me doing the talk every single time. And it is just because of the sheer amount of data. So I want to end on the... the three ways that you end up thinking you've spotted a pattern. If you've got enough data, you can find anything you want. We want to find these patterns, and we don't appreciate just how likely some of them are. And I thought, just to show you, just as a finishing point, the predictive power of this. Because some of you are still looking for words, I can tell. And I'll save some of you the pain to predict what's going to happen in the future, because there's still some of today left. Who knows what could happen today? We should check. Well, the word drink appears there. This is more aimed at the organisers and those of you above 18, but bear with me. But drink what? You're thinking? Of course, ale appears up the top there. So I hope that's inevitable. I'm going to finish by taking that E, taking that D, in between it exactly is an N. So we've got the word end there, and it's there, and it's there, and there, and there, and there, and one of it. Oh no, that's all of them. There are actually 10 of them. Where are we? So I should, there. There's 6. There are another 4 to find if you get bored. But I am going to end on that. You guys have been fantastic. Thank you very much.
Evolutionary advantage to being able to spot patterns, but surely there's also an evolutionary advantage to being able to calculate risks accurately. Why are we so bad at it?
The question was, I mentioned an evolutionary benefit to spotting patterns, but wouldn't there be an advantage to be able to calculate risks? And I'm not an evolutionary biologist or behaviorist or anything else that begins with B, but to my lay understanding of this, you want to overestimate your risk, because there's no harm in running away if there wasn't a danger, but there's a big price to pay if you don't run away and there is danger. And so we are hardwired to overestimate the odds of something happening, because a false positive is dramatically safer than getting eaten by a mammoth. That sentence got less factually correct as it went on, I'll be honest. Fill in your own hilarious prehistoric animal. Good.
Is there any chance of you actually playing the piano?
No. It's not only is it small, it's 0. That's.
I was wondering whether you've heard of kind of a pattern that was spotted in like this text on font on computer called Wingdings, where you typed it. You've heard of it, haven't you?
The font, yes.
Yeah.
Technically typeface, and seeing how we're all pedants here tonight.
Yeah, and you typed in 911 and then the airplane number that crashed into the thing.
Okay, this was, if you get the Wingdings font / typeface, and you bring it up, and what Microsoft thought was it would be a good way to have lots, it was like a precursor to clip art. So it was a typeface that was just characters instead of letters. It comes in as the second most annoying typeface ever, slightly behind Comic Sans. Possibly the best titled typeface ever. And if you put in 911, it shows a plane flying into 2 rectangles. Some would say, not in good taste. But the problem with that is, after 9/11, after a tragedy of that magnitude, it's burnt into the public conscious. Even people who were born since then are aware of it and all the visual aspects and the notion of it and everything that goes with it. And so if there's anything out there that accidentally looks like that or looks like a coincidence, it will be found. Same thing happened when Michael Jackson died. Because people started filming everything around his house, and sure enough, a bit of footage showed up with a shadow that looks like the ghost of Michael Jackson. It's because when something that big happens, people look everywhere for a freaky part of it. And I would be amazed if there's ever something of that scale and then you don't get something like that popping up. The trouble is, when you see that, because it was an email forward a couple of years back, went around, you see that and you're freaked out, but you never see the thousands of people who are at home. They've gotten tired of listening to records backwards. And so they decide to search for other meaningless patterns. And you don't see that, you just see the amazing result. A longer answer than was required, but I enjoyed it. There's that guy who looks a bit too learned for my liking.
Do you have anything to say about data mining and the supermarkets and your shopping?
Do I have anything to say about data mining and the supermarkets and shopping? And personally, I think life's too short for loyalty cards, to be entirely honest. And I think it's a bit of a false economy anyway. No, it's not. It's a tax on people like me who can't be bothered to carry one around. But if you collect enough data and you process it well, incredible things happen. A lot of our modern medical breakthroughs are because of our ability to collect lots of meaningful data and process it in a meaningful manner and get proper results out. And supermarkets aren't stupid. Amazon isn't stupid. Google isn't stupid. They have huge amounts of data, and it's incredible things you can do with it. Really, really freaky things. Amazon's book, where it predicts a book you might like, it gets scarily accurate. And it's because they're using data correctly. Personally, I have some hypothetical liberties issues with quite how it's done, but I like the concept, and I think it's more benefit than harm, to be entirely honest. But that's, yeah. Data mining is a good thing, but can be used for evil. Much like the internet. People do need to leave for trains. I've heard some of you have homes to go to. So we may have to wrap this up fairly quick.
Just a very quick, simple one then. Would you play a lottery ticket with 1, 2, 3, 4, 5, 6 on it?
Would I play a lottery ticket with 1, 2, 3, 4, 5, 6? I do play the lottery. Because a non-zero probability, however small, can still happen. Winning the lottery is still slightly more likely than me playing that piano. But the trouble with 1, 2, 3, 4, 5 is I forget how many people play that same number. If you want to win the lottery and not share it with anyone else, you want to pick numbers which are bigger than 31, because people like to pick birthdays, and you want them to be randomly spread out. And it's harder than you think to do that. But if you do win, then you've got less chance of sharing it with someone else. So I would not play one or any other. I often play prime numbers, to be honest. If you want to know my secret, it's or primes. One day.
Any other questions?
I will loiter afterwards if people have overly personal maths questions or anything we didn't get to. Come and see me.